Okay, this is going to be a video on log and exponential graphs, new for this year. The big thing I want to talk about is how to find the asymptotes, all right, from your, so if you have a log, any base, here are all examples of logs. Okay, so let's start out with these. These are all examples of logs. Okay, now logs, and what they call that is a natural log, okay, all have vertical asymptotes, okay, all right? The graph is gonna look like this, or the graph is gonna look like this, okay? They have vertical x equals base asymptotes, okay? They've got vertical asymptotes. All right. Now, to find that vertical asymptote, what you're going to do, okay, and this is basically the same for exponentials, okay? You solve the inside and then use the outside, okay? So this would be -1, -3, okay? So my vertical asymptote would be x equals -1. This one, if I solve this, would be 4. Use that, that's 1, so that's gonna be x equals 4. Okay, this would be, solve that, that's -3, that's -4, so that'd be x equals -3. All right, solve that, that would be -2. Use that, be -3, be x equals -2. Okay, so that would be your vertical asymptotes. Okay, all right. All right, for exponentials, here's all examples of exponentials. Okay, now the inside part of it, so for exponentials, okay, they have horizontal asymptotes. Okay, which is a y equals base equation that goes like this. So your graphs are either going to be like this, or they're going to be like this. Okay? All right. So, same deal. This is considered inside the function. Okay? All right. So if I solve that, that'd be -1. Use that, that'd be -4. Okay? But this is going to be y equals, so it's going to be -4. Okay, solve that would be 3. Use that would be 7, so it's going to be y equals 7. Okay, solve that, which is -1. Use that, which is -3. That's going to be y equals -3. Solve that, that would be 0. Use that, that'd be 3. It'd be y equals 3. So you got to be able to find those asymptotes first. Okay. Now, we're not going to concern ourselves with the x-intercepts here, but let's talk about how you graph these equations. Okay, so the first thing you want to do is come up with the asymptote. I want to solve that, would be 2, use that, which is -7. So this is going to be y equals -7. 1, 2, 3, 4, 5, 6, 7. So I make that through there. Okay, now what I want to do, just like I've done all my graphing, want to do very similarly, okay? All right, 0, -1, -2, 1 and 2. I'm using 3 to the x power. 3 to the 0 will be 1. 3 to the first will be 3. 3 to the second would be 9. All right, and then what these do, this becomes 1/3 and this is 1/9. And the reason for that is the exponent properties, the negative exponents flip. Okay, so now, just like before, solve the inside would be 2. okay? Check my interval, okay? Well, the number attached to x is 1, so it's just going to be 1. So this is going to be 3, 4, 1, 0. Change the outside. Now, we're not multiplying by 3. We'll talk about some of that in a second. I'm going to subtract 7. Okay, so minus 7, okay? The fractions can get a little bit tricky, okay? All right, but if I subtract 7 from that, that's negative 6, negative 4, that'd be 2, okay? Subtract 7 from that would be like negative 6 and 2/3, okay? Negative 6 and 7/9, okay? All right, so I plot those, okay? All right, plot those points, all right? I'll start with this one, 2 over, negative 6 down, 3 over, negative 4 down, 4 over, 2 up, okay? This is 1 over, negative this, and then negative this. Okay, so this is what I got. Okay, I'm not going to worry about the x-intercepts. Okay, my domain, when I do label the domain, this is positive infinity, positive. Okay, this one, when I label this arrow, okay, all right, the big thing is, what's my asymptote? My asymptote equation is y equals negative 7. So that's going to be my y coordinate. So whatever that letter is, and this would be the negative infinity, okay? So my domain is negative infinity to infinity. My range, my smallest y is negative 7. I do a curved bracket because that's an asymptote. My biggest is infinity. Start from the left. It's going to be negative infinity to infinity, and this will be none. And we're not going to worry about those for right now, okay? All right. Now, you get something like this. All right, what's this one going to be? Well, I want to solve the inside, 0, keep the outside, 5. So that's going to be y equals 5 is going to be 1, 2, 3, 4, 5. Okay, it's going to be my asymptote there. All right, so I got negative 2, negative 1, 0, 1, and 2. 2 to the x power in this case, I'll get into that negative in a second. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. That would be 1/2, 1/4. Okay, so now what I want to do here, all right, if I solve that inside, it's still going to be 0. That interval is still going to be 0 there. I'm going to add 5 to this. But the other thing I have to do is, because that negative is there, I got to multiply by negative 1 and then add 5. Okay, so that'd be negative 1/4, that'd be negative 1/2, that'd be negative 1, that'd be negative 2, that'd be negative 4. Then if I add 5 to that, I don't need to show that while I'm doing that. Okay, that would be 4.75, that would be 4.5. That would be 4, would be 3, and 1. Okay, so what I'm going to graph are these points. Okay, so 2 over 1 up, 1 over 3 up, 0 over 4 up, negative 1 over 4.5, negative 2 over 4.75. So this is what it looks like. Okay, this would be positive infinity, negative. This is the line y equals 5. That's 5 and negative infinity. Okay, so my domain, negative infinity to infinity. My range, my smallest y value is negative infinity. That's going to be 5. Okay, curved bracket there. All right, this would be a decrease the whole way from negative infinity to infinity. So we not. Okay. All right. Okay, let's do one more. Let's say I have y equals 4 to the x minus 2 minus 8. Okay. So solve the inside, that's 2. Solve the outside, that's negative 8. Okay. All right. So my asymptote is y equals negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, should be a dashed line. Didn't come out that great. All right, there we go. There's my asymptote. Okay. Okay, now I'm doing 4 to the x. 4 to the 0 is 1. 4 to the first is 4. 4 to the second is 16. That's going to be 1/4, 1/16. Okay. Solve the inside. That'd be 2. So this is going to replace the 0. Interval will be 1. Okay. All right. Interval will be 1. Okay. So that'd be 3 and 4. 1 and 0. Okay. All right. Now, what I want to do here is subtract 8. Okay, so that's going to be negative 7.9 something. That's going to be negative 7.75, negative 7, negative 4, and 8. Okay. So I got 2 over negative 7 down, which will be here. 3 over negative 4 down. 1, 2, 3, and 4. 4 over 8 up. Will be somewhere up here. Then 1 over 7.75. So it looks something like this. Infinity, infinity. This would be negative infinity, negative 8. Okay, so my domain is negative infinity to infinity. Okay, and my range, my smallest value is negative 8, biggest is infinity. This is increasing the whole way. Okay, that would be none. Okay, all right. All right, so that is those. Okay, I'm going to get into natural log, or I'm going to get into the base exponential later. I want to talk about log values. Okay, y equals log base 3 of x plus 5 minus 1. Okay, so if I solve the inside, it's negative 5. Keep the outside, it's negative 1. I've got an asymptote of x equals negative 5. 1, 2, 3, 4, and 5. So that would be here. Okay. Now, what I want to do with this, I'm going to talk about this for a second. Okay, I would do log 3 of x. Now, what you'll learn about logs, okay, is that you can't have a negative log. Okay. All right, so these you can't use, okay? All right, log to the 0 is undefined, okay? So you really can't do anything with that. In this case, that accounts for the vertical asymptote, okay? But log 3 to the 1, anything to the 1, that's gonna be 0. Now, to make this next point easy on yourself, whatever the base is, just make that the same number. So I'm going to change that, all right, to a 3, okay? Because this to this will be a 1, okay? All right, it's sort of similar to square root from a calculation standpoint. Now, I want to solve this. This would be negative 5, okay? All right, if I solve the inside, the interval is still 0, okay? All right, if I go to solve this, this is negative 5, so now it would be negative 4, this would be negative 3, this would be negative 2. Okay, I want to subtract 1 from this, undefined is not going to change, that's going to be negative 1, that is going to be 0. Okay, so what I have, I already got negative 5, that's undefined, negative 4, negative 1. Okay, and I got negative 2 over 0 up. So here's what this looks like. This approaches here. We don't get as many points with this as the other ones, but that's what you have to know the shape looks like. Now, this asymptote, is x equals -5, so that's -5 there. Negative infinity, because that's going down. That's negative infinity, positive infinity. Okay, so my smallest x value is -5. Biggest is infinity. Oops, that should be positive, sorry. My range, my smallest is negative infinity. Biggest is positive infinity. This is increasing from -5 to infinity, and this is not decreasing. Okay? All right, let's do another one. Okay, so on this one, what I want to do, okay, all right, I want to solve the inside would be 3, keep the outside, which is 1. My asymptote here is x equals 3. Okay, so I got 3. All right, now when I go for this one, I'm doing y equals log 2 to the x. Now I can't use this, and I know that 0 is going to be undefined. Log to the 2, 1 is 0. Now, since those are the same numbers, I automatically know it's that. Okay? So then this one, if I solve the inside, that'd be 3. The interval makes that 4 and then 5. Okay? And then I would add 1 out here. So that's still undefined. That's 1, that's 2. Okay? So 3 over undefined, that's fine. 4 over 1 up. 5 over 2 up. And what I gotta know is that it goes through those points and heads that way. Okay? So this is 3 negative infinity. This is positive, positive. Okay? And so my smallest x is 3. My biggest is infinity. My smallest y is negative infinity. My biggest is positive. Okay, this is increasing the whole way, so 3 to infinity. It's not decreasing at all. Okay, let me do one more with you. Oops. We got y equals negative log 4 x plus 6 plus 3. Okay, so I'm going to solve the inside. It's -6, 3. So my asymptote is x equals -6. 1, 2, 3, 4, 5, and 6. Would be that. Okay, all right. So I know I can't use this, no, this is undefined. Log 4 to the 1 will be 0. Now, normally, I would want to pick something that's the same, so I'm going to use 4 because that's going to be 1 there. Okay? Now, what am I going to do here with this? Actually, hold on, let's get to the x value. If I solve this, that's going to be -6. Interval will be, that's going to be -5, -4, -3, this will be -2. Okay? Because I have a negative out there, I want to multiply by -1 and then add 3. So that's going to be still undefined. That's going to be 3. -1 plus 3 would be 2. Okay? So -5 over 2, 3, 4, 5, 1, 2, 3 up. -2 over 2 up. So now what this is going to do is it's going to go this way. Okay? That's still going to be -6. Now positive infinity because it's going up. That's positive negative that way. So my smallest x value there is -6. My biggest is infinity. My smallest y value is negative infinity. Biggest is positive infinity. Okay. This is going to be decreasing the whole way from -6 to infinity. And that's going to be nothing. Okay. All right. Now, let's go ahead and finish with two more where the intervals change, one each for log, one each for exponential, okay? So let's say I've got let's say I have, oh, no, I don't want to do that. All right, so let's say I have something that looked like this, okay? All right, so what I would have, if I solve that inside, that'd be -5, -1, okay, which meant that I'd be at y equals -1. Okay, so I make my table. Three to the x power, okay? So 3 to 0, 1, 3, 9, 1/3, 1/9. Okay, if I solve the inside, that's gonna be -5. Okay, my interval, 1 divided by the number in front of x is 1/2. So this would be -4.5, this would be -4, this would be -5.5, this would be -6. Okay. I'm going to subtract 1 by all these. So it's going to be -8/9. Okay, 1 minus 1/3. 0.3 minus 1/3. Negative point. -0.66. Okay. All right. This would be 0. This would be 2. This would be 8. Okay. All right. So I got -4 over. Eight up. 6, 7, 8. Got -4.5 over 2 up. Okay, I've got -5 over 0 up. I got -5.5 over this and this. So I got this going on here. Okay, so what's that asymptote going to be? That's going to be -1, -infinity, +infinity. Okay, so my domain, -infinity to infinity. My range, -1 to infinity. Okay, this is increasing from -infinity to infinity. This is none. Okay. All right, and then let's do one with log. Let's not put this, just do this. Okay, so I solve the inside, that's -2. There's nothing on the outside, so that's going to be 0. So I've got an asymptote of x equals -2. All right. And so I want to make my my chart here. I've got x and y. I'll do log 2. -2, -1, 0, 1, and 2. These I can't use. This I know is undefined. 2 to the 1 is 0. 2 to the second would be 1. Okay, now I would solve the inside. So that would be -2. Okay, now I do 1 divided by 3, which is 1/3. So that's going to be -1.6, then -1.3. Okay, all right. I'm going to do nothing to this part because there's nothing outside there. So -1.6 over 0 up, -1.3 over 1 up. So the graph is going to do this. Okay, infinity, infinity. This is -2, -infinity. So my smallest x value is -2. biggest is infinity, okay? Negative infinity to infinity is the range, okay? It is increasing from -2 to infinity. It is none of this, okay? All right, and then that's those, all right? So what I want you guys to do, I'm gonna give you a bunch of these to try on your own. Hopefully we're getting no duplicates here. All right, but I would like you guys to do these. Just wanna make sure I didn't give you that one. No. Okay, I'd like you guys to do those.